Hi, my name is Yihan Wang,
And my name is Emma Wang.
and our project started with a simple question of if sunscreen is supposed to protect us, why do some of its ingredients raise concerns about irritation, instability, or environmental damage?
We began our research within the simple premises that skin cancer is extremely common and sunscreen is the most recommended instrument of prevention. Upon deeper investigation, however, we realized that many commercial sunscreens rely on chemical UV filters that can cause allergic reactions or accumulate in marine ecosystems. We became curious whether a natural alternative, specifically seed oils, which harvest in antioxidants and polyphenols, could meaningfully contribute to UV protection in a safer and more sustainable way.
To test this, we created several sunscreen formulations using coconut oil and shea butter as a base with zinc oxide, and then added either raspberry, carrot, or rosehip seed oils. We compared these experimental groups to both a commercial L'Oreal SPF 50 sunscreen and a homemade control without any seed oils. But we didn't just want to measure UV absorbance on a surface. We also wanted to model biological impact. So we cultured chlorella vulgaris microalgae biofilms and will use them as a simplified model for how living cells respond to UVB exposure. After exposing both quartz plates and biofilms to controlled UVB radiation, we will measure transmitted light intensity and quantified cell death.
The most interesting result was that the raspberry seed oil formulation consistently showed the lowest transmitted UVB intensity, meaning it absorbed or reflected the most radiation. Its average transmitted intensity was about 34.5 milliwatts per meter squared, compared to the around 38 to 40 milliwatts per meter squared for the other formulations. Even compared to the commercial L'Oreal sunscreen, the raspberry formulation performs slightly better in relative UV attenuation within our system. With further relative comparisons, we determined that within the same experimental setup, raspberry oil enhanced photoprotection beyond zinc oxide alone. In our evaluation of results, we realized that raspberry seed oil most likely succeeded beyond other experimental groups as it contains ellagic acid and tocopherols, which are known for their antioxidant and UV absorbent properties. It's likely that these compounds contributed to the increased UV attenuation. In contrast, carrot and rosehip seed oils didn't show the same enhancement, which suggests that not all natural ingredients are equally as effective.
There were also few limitations that shaped how we interpreted our results. The UV lamp intensity fluctuated unpredictably, which may have influenced absolute SPF calculations. Temperature shifts in the lab affected formulation texture, and the SPF method we used was based on transmittance averages rather than spectrophotometric weighing across wavelengths. Instead of weakening the project, these challenges actually deepened our understanding of experimental design and how careful interpretation matters as much as raw data.
Being able to conduct and experience this research overall strengthened our interest in applicable science, especially where environmental responsibility and human health collide under one prevailing problem. We would like to continue exploring the process of translational research in the future and hope to produce meaningful results like the ones we have gained from this project. Thank you for considering our application.